Welcome back, everybody, to another deep dive. This time, we're going to be tackling something that I think is really fundamental to how we think, not only in math, but just like everyday life.
Hmm.
And that is inductive reasoning.
Oh, yeah. It's so fascinating how we use this type of reasoning to just navigate a world that's really full of uncertainty.
Hmm.
Instead of dealing with absolute proof, we're kind of making judgments based on, the evidence we gather.
Yeah, it's like you're trying to solve a puzzle, but some of the pieces are missing.
Right.
And you have to kind of use what you do have to make some educated guesses about the big picture.
Yeah.
And that's where our source material comes in. Mathematics and Plausible Reasoning by G. Polya.
Polya, he was really like a giant in the field of problem solving.
Oh, absolutely.
His work really stresses the importance of this type of reasoning. And, not just in math.
Right.
It's really in any field where we have to make decisions based on incomplete information.
So really, our mission today is to understand these patterns of plausible reasoning, how they connect to like the concept of probability and why they matter, beyond just solving equations.
I think a good way to think about it is, deductive reasoning is like following a recipe. You have all the ingredients, you have the instructions, and you're guaranteed a specific outcome. But plausible reasoning is more like being a detective. You're gathering clues, you're trying to build a case, but you can never be 100% certain.
Right. Right.
So instead of absolute proof, we're talking about making a conjecture more credible through evidence, like gathering enough clues to confidently say, okay, this is the most likely scenario, even if there's like a tiny chance you might be wrong.
Exactly. And Polya identifies several key patterns in how we go about this process of making things more believable.
All right, let's dive in. The first one is verification of a consequence. So if our conjecture leads to a specific prediction, and that prediction turns out to be true, it just strengthens our belief in the original conjecture. I think a great example of this is Euler's conjecture about numbers of the form 8 plus 3. He couldn't prove that any number in that form could be expressed as the sum of the square and twice a prime number, but he tested it out.
Oh, wow. So he was just kind of plugging in numbers and seeing if it worked.
Yeah, and it's actually really amazing to see. Polya includes a table in the book, and it shows Euler's work, and he's very methodically calculating the sums for these numbers, like 11, 19, 27, all the way up to 83, and each time it fit the pattern.
So even though Euler couldn't like mathematically prove his conjecture, seeing all those examples makes it a lot more believable. It's like saying, well, it worked for all these cases, so it's probably true in general.
And that's really a key takeaway here. This repeated verification of a conjecture's consequence, even without a formal proof, can really boost our confidence in its truth. And it's a cornerstone of how we kind of navigate uncertainty in all sorts of situations.
Okay, that makes a lot of sense. Building on this idea of verification, let's look at the next pattern. Variety of consequences. It sounds like it's not just about the amount of evidence, but also the kind of evidence we gather.
Exactly. So imagine you're testing like a new scientific theory. Would you be more convinced if it explained like a bunch of really similar phenomena, or if it successfully predicted outcomes in like wildly different areas?
Definitely the second one.
Right.
It'd be way more convincing if the theory could explain things that, at first glance, seem completely unrelated.
Absolutely. A great illustration of this is like the formula for the volume of a cone. This formula isn't just like a random guess. It's supported by checking it against cylinders, cones, even more complex shapes.
Mhm.
And it holds true across all these different, geometric cases.
So by applying the same formula to different shapes and getting consistent results, it strengthens our belief in the formula's validity. It's like getting confirmations from multiple independent sources instead of just like echoes of the same information.
Now, let's move on to a pattern I find particularly intriguing. Surprising consequences. This is where things get really interesting.
Okay, lay it on me. What's so special about surprising consequences?
Think of it this way. Imagine someone makes a prediction that seems far-fetched. If that prediction turns out to be true, wouldn't that make you take them a lot more seriously?
Wow, yeah, that is fascinating. I never really thought about it like that, but like improbable events kind of hold more weight in our reasoning.
Right.
It's like if someone predicts something that's mundane and it comes true, you'd be like, well, yeah, that was obvious. But if they predict something totally out there and they're right, it's like, hold on, there must be something to what they're saying.
Exactly. And Polya even delves into the psychology behind this. He explains how our intuition is naturally more swayed by these surprising confirmations.
This is making me think about, like, all those times I dismissed someone's idea as crazy,
Right.
only to be totally shocked when it actually worked. Maybe I should be more open to, like, unexpected possibilities.
Yeah. It's a good reminder that sometimes the most groundbreaking discoveries come from challenging our assumptions and considering ideas that initially seem like totally outlandish.
All right, on to the next pattern. This one is inference from analogy. I'm guessing this is where we start to, like, draw parallels between different things to support a conjecture.
Yes, and this is where things can get a bit tricky.
Okay.
So while analogies can be powerful tools, they can also be misleading.
So how do we know if an analogy is actually valid and not just a superficial similarity?
Polya uses the example of the isoperimetric theorem to illustrate this. Now, you might not be familiar with the mathematical jargon,
Yeah, I'm not.
but the basic idea is that for shapes with the same perimeter, the circle encloses the largest area.
Oh, okay. Yeah, I can kind of picture that. So what's the analogy here?
Well, Polya draws a parallel between this geometric principle and something that's observed in physics with like vibrating membranes. And you can actually see this in the book. He provides a side-by-side comparison in tables. He's showing how these seemingly unrelated things exhibit a really similar pattern.
Wait, so you're saying shapes and vibrating membranes follow a similar rule about, like, maximizing something within a fixed boundary.
Mm.
I never would have guessed that those two things would be connected.
Right. It's really fascinating.
Yeah.
It's an example of how analogy can help us see, unexpected connections and gain new insights.
Okay, I'm starting to see how powerful analogy can be as a tool for plausible reasoning. But you mentioned it can be misleading.
Right.
Could you give an example of when an analogy might lead us astray?
So imagine you're trying to understand, like, the human brain. You might be tempted to draw an analogy to a computer, since both process information. However, that analogy kind of breaks down when you consider things like emotions, consciousness, creativity. Like, these are aspects of the human experience that are really difficult to map onto the workings of a computer.
That's a really good point. So while analogies can be useful starting points, we need to be careful not to overextend them or draw conclusions based on just, like, superficial similarities.
Exactly.
So far, we've covered verification of a consequence, variety of consequences, surprising consequences, and inference from analogy. Are there any other patterns we should know about?
There's one more. Fruitless efforts. And this one might seem a little counterintuitive, but it's actually really insightful.
Okay, I'm intrigued. Tell me more about fruitless efforts.
Think about like a problem that many brilliant minds have struggled with for years, even centuries, without finding a solution. After a while, doesn't it become plausible to consider that the problem itself might be impossible to solve?
Yeah, that's an interesting way to think about it. It's like, if all these incredibly smart people have, like, hit a dead end, maybe there's a fundamental reason why it's just not working.
Exactly. And it's not about giving up easily, but rather recognizing that sometimes learning what doesn't work can be just as valuable as finding a solution.
Yeah.
It helps us refine our understanding of the problem and its limitations.
Can you give me an example?
Yeah, take like the classic problem of squaring the circle.
Okay.
This stumped mathematicians for centuries. They tried countless approaches, but nothing worked. Eventually, it became increasingly plausible that the task itself was impossible, which was eventually proven to be true.
So in a way, all those failed attempts were actually valuable pieces of evidence pointing toward, like, the inherent impossibility of the task.
Right. And it's not just limited to math. Think about, like, the quest for perpetual motion machines.
Right.
Centuries of failed attempts led physicists to formulate this principle of, like, the impossibility of perpetual motion,
Yeah.
which then became a cornerstone of, like, thermodynamics.
This is really making me think about how much we rely on plausible reasoning in all aspects of our lives, even when we don't even realize it. It's how we navigate a world where complete certainty is often really elusive.
And that brings us to another really important distinction. The difference between plausible reasoning and actual proof.
All right, let's unpack that.
So, plausible reasoning, it can guide us towards likely conclusions. But it's not a guarantee of truth. It's like using a flashlight to navigate a dark room. It illuminates the path ahead, but you still need to be careful not to trip over obstacles.
So how do we avoid those, like, metaphorical stumbles? How do we know when we're relying too heavily on plausibility and need to dig deeper for more, like, concrete evidence?
Polya offers a really fantastic anecdote that illustrates this perfectly.
Okay.
It involves a Reverend Galliani and a dice thrower. Initially, when the dice thrower rolls 3 6s in a row, yeah, you might just think he's lucky. Improbable things happen, right?
Yeah, but wouldn't your skepticism start to creep in if he kept rolling 3 6s over and over again?
Exactly. And that's what happens in the story. The dice thrower keeps rolling those triple sixes, not just once or twice, but 5 times in a row. And Polya details this increasing improbability of each consecutive roll, highlighting this shift from, like, plausibility to suspicion.
So we're essentially using probability as like a guide. At some point, we have to say, hold on, the odds of this happening randomly are so astronomically low that there must be another explanation.
That's exactly the question that Polya wants us to grapple with. Even highly improbable events can happen by chance. But there's a point where alternative explanations become more plausible.
It reminds me of Occam's razor, the idea that the simplest explanation is usually the best. In this case, maybe the simpler explanation is that the dice are loaded.
Exactly. And this is where things get even more interesting.
Because now we're talking about the human element, right?
Right.
Like our own judgments and biases can come into play.
Polya makes this point quite eloquently. He says, you can build a machine to draw demonstrative conclusions for you, but I think you can never build a machine that will draw plausible inferences.
So you're saying that plausible reasoning isn't just a cold, hard calculation. It's a deeply human process, influenced by our experiences, our beliefs, even our gut feelings.
And that's what we'll explore in the next part of our deep dive. Stay tuned.
Stay with us. Welcome back. Last time we were exploring these different patterns of plausible reasoning, like how we use evidence to make conjectures more believable. But I'm ready to see how all this, plays out in the real world.
Well, Polya spends a lot of time examining how plausible reasoning works in the legal system,
Okay.
particularly like in a courtroom when you're trying to determine guilt or innocence.
Oh, this is giving me like Law and Order vibes.
Yeah.
I'm picturing like a tense courtroom scene, dramatic music is playing.
Right. Think about it. You have a conjecture this person committed the crime, and then you have all these different pieces of evidence. Witness testimonies, fingerprints, maybe a recovered weapon. But none of this is absolute proof.
Right. It's all about like building a case piece by piece. Like if the suspect's fingerprints are found at the crime scene, that's like a pretty big piece of the puzzle.
It is. But let's break it down, like using the framework of plausible reasoning. We have to ask ourselves, like, two key questions. First, how well does the evidence explain the conjecture, if it were true? And second, how probable is that evidence regardless of whether the conjecture is true?
Okay, so in this case, if the suspect did commit the crime, finding their fingerprints at the scene makes total sense. But, I mean, couldn't those fingerprints have gotten there some other way? Like,
Right.
what if the suspect was there earlier that day, but for a completely innocent reason?
Exactly. So the strength of the evidence depends on how much more likely it is, if the conjecture is true. The prosecution's job is to show that, the evidence points strongly towards guilt. They might say, well, the prints were found on the murder weapon, not a doorknob, making that innocent explanation a lot less likely.
Ah, I see. So it's not just about whether the evidence, like, could fit with the conjecture, but how probable that scenario is compared to other, like, possible explanations.
And the defense has a role to play here, too. They might introduce a counter-conjecture. They might say someone planted those fingerprints there to frame the suspect.
Oh, interesting.
And then they would present evidence to support that claim.
So it becomes this like back and forth. Both sides are trying to like tip the scales of plausibility in their favor. It's like a mental tug of war using evidence as the rope.
Yeah. And it really highlights the importance of, weighing all the evidence, not just focusing on the pieces that support one side of the argument.
This makes me think about all those true crime documentaries where you see like these seemingly airtight cases totally fall apart when new evidence comes to light. It really shows how plausible reasoning is an ongoing process. You're
Right.
constantly updating your assessment as like new information comes in.
And it's important to remember that in complex situations like this, we're dealing with probabilities, not absolutes.
Right. But this is where things get really tricky, isn't it? Because even the most objective evidence can be like interpreted differently by different people. Our own biases and experiences inevitably, shape how we view the world.
You're absolutely right. That's why Polya really emphasizes the importance of being aware of, our own biases.
Yeah.
And how those biases might, influence our judgments. He provides a really thought-provoking example to illustrate this.
Okay, I'm all ears. Let's hear it.
So imagine two people. We'll call them person A and person B. They're both looking at the same set of evidence, right? Related to a conjecture. Now, they might agree on all the facts of the case. but their backgrounds and experiences could lead them to vastly different conclusions about how likely that conjecture is.
So it's like two people looking at the same painting, but they're seeing completely different things. How's that even possible if they're both like looking at the same objective evidence?
Let's say person A, they've spent years working in a field where they've just seen countless examples of, a certain type of claim turning out to be false. That experience might make them more skeptical of new evidence supporting that claim, even if it seems really strong on the surface.
So their past experience is acting like a filter, influencing how they interpret like new information. It's almost like they're subconsciously looking for evidence to confirm their existing beliefs.
It's a very natural human tendency, and it highlights the importance of being open to different perspectives, considering alternative explanations, even if they challenge like our preconceived notions.
This makes me think about the importance of like diversity in any situation where you're trying to make sense of complex information. If everyone around the table has the same background and experiences, there's a much greater risk of like groupthink.
Right.
And you might miss some really crucial insights.
You're absolutely right. By bringing together diverse viewpoints, we can really challenge each other's assumptions, identify blind spots, and ultimately reach like more well-rounded judgments.
Okay, I'm really seeing how plausible reasoning goes beyond just connecting the dots.
Hmm.
It's really a dynamic process,
Yeah.
influenced by both logic and human psychology.
And this applies not just to like the legal system, but to many other areas of life, including scientific discovery.
Oh, I bet you have a fascinating example up your sleeve for this one.
Well, think about Ignaz Semmelweis.
Yeah.
He was a Hungarian physician who, in the mid-1800s, made a groundbreaking discovery about childbed fever, a really deadly condition that was just like rampant in maternity wards at the time.
Oh, wow, yeah. So tell me more about Semmelweis and his discovery.
So he was working in a hospital that had two separate maternity clinics, and he noticed this shocking difference in the death rates from childbed fever between the two clinics. One clinic that was staffed by, doctors and medical students had a significantly higher mortality rate than the other clinic, which was run by midwives.
Wow, that's a huge discrepancy. Does anyone have any idea what was causing it?
Well, at the time, no one really understood what caused childbed fever. They considered things like overcrowding or differences in, the air quality, but nothing seemed to fully explain this pattern.
So he was faced with this, like, medical mystery, a puzzle with some very important pieces missing.
Right.
So what did he do?
So he meticulously investigated, looking for any differences between the two clinics that could explain the discrepancy. He considered a wide range of factors, the physical environment, the religious practices of the patients, but none of it really provided a satisfying explanation.
So it was like a process of elimination? He was trying to rule out all the implausible explanations to see if anything remained that could help him make sense of the data.
Exactly. And then a tragic event occurred. A colleague of Semmelweis died from an infection after being accidentally pricked with a scalpel during an autopsy. And the symptoms were strikingly similar to childbed fever. And this kind of sparked a really crucial insight.
Wait, so he's thinking, could something from the autopsies be contaminating the doctors and the students and then being passed on to the mothers in their care? That's a pretty bold connection to make.
It was a leap, but it was a plausible one based on the available evidence. So to test his conjecture, he implemented a strict hand-washing policy in the doctor's clinic, requiring everyone to disinfect their hands with a chlorine solution before examining patients.
Okay, this is getting good. What happened?
The results were dramatic. The mortality rate from childbed fever in that doctor's clinic plummeted. It fell to levels comparable to the midwife's clinic. And this provided really strong evidence in favor of his conjecture.
So it wasn't absolute proof, but it significantly shifted the balance of plausibility. The hand-washing policy made his conjecture, like, way more believable, even though he didn't fully understand the, like, underlying mechanism at the time.
Exactly. It took years for the germ theory of disease to be fully accepted, which really explained why his intervention worked. But even without that complete understanding, his use of plausible reasoning led to a life-saving discovery.
This story is a powerful reminder that we don't always need absolute certainty to, like, make progress.
Right.
Sometimes it's about making the best judgment you can based on the evidence you have,
Mm-hmm.
even if it means, like, challenging the conventional wisdom.
And this really highlights why plausible reasoning is so crucial in fields where knowledge is, like, rapidly evolving.
Yeah.
Like in scientific research
Or in the development of artificial intelligence.
Right.
We were starting to get into this at the end of last part.
Exactly. We're now asking these AI systems to do some pretty complex things like diagnosing diseases, driving cars, making like financial decisions. And these aren't situations with like clear-cut answers. They often involve incomplete information, uncertainty, and the need to weigh all these different possibilities.
So it's not just about programming AI to follow a set of rules.
Right.
We need to equip them with, like, the ability to reason through uncertainty, just like humans do,
Mhm.
but without the benefit of all our life experiences and intuition.
Exactly. And that's why researchers are really exploring how to incorporate the principles of plausible reasoning into these AI algorithms. Like one approach is to train these AI models on massive data sets, allowing them to kind of learn these patterns and make inferences based on, statistical
It's
probabilities.
just like teaching AI to think like a statistician. Feed it enough data, and it starts to see the world in terms of, like, likelihoods rather than absolutes.
Yeah. Yeah, that's the idea. By analyzing huge amounts of data, AI can start to identify these correlations, make predictions, even generate hypotheses, much like a scientist, conducting research.
This is pretty mind-blowing, but I can't help but think about the potential pitfalls here. What if the data itself is biased?
Right.
Wouldn't that bias then be reflected in, like, the AI's decisions?
That's a huge concern, and one that AI researchers are really actively working to address. If an AI is trained on data that reflects existing societal biases, its outputs are likely to reflect those same biases.
So it's not just about the quantity of data, but also the quality and, like, how well it represents the real world.
You've hit the nail on the head. We need to ensure that the data used to train these AI systems is diverse, it's unbiased, and it's really representative of the population that it's intended to serve.
This is making me think about the importance of, like, human oversight in the development of all this AI. We can't just hand over all decision-making power to machines without carefully considering the ethical implications.
Absolutely. That's an incredibly important point, and one that we'll explore further in the final part of our deep dive. Stay tuned.
Welcome back to our deep dive into plausible reasoning. It's crazy to think about everything we've already covered, like all those basic patterns and how it works in legal cases, and even in those scientific discoveries.
Yeah, and now we're finally here, ready to tackle what I think is the most fascinating frontier of it all. It's like how plausible reasoning is,
Hmm.
shaping how we're developing artificial intelligence.
Yeah, last time we were talking about how all those researchers out there are training AI on, like, tons and tons of data. It's almost as if we're, like, teaching them to think like statisticians.
Hmm.
But then you also brought up some pretty serious ethical questions, like what about bias and all that data?
Yeah, it's definitely a challenge, and it's something AI developers think about all the time.
Mhm.
If you use data that reflects existing societal biases to train an AI system, well, those biases could very well end up in the AI's decisions too.
So it's like what they say, right? Garbage in, garbage out.
Exactly.
So if you feed a system like bad information, then you're going to get bad results.
Exactly. Like, let's say you're trying to develop an AI to help with hiring.
Okay.
If you train that AI on data that reflects historical hiring patterns, but those patterns were discriminatory, maybe certain groups were underrepresented,
Right.
well, the AI might just keep those biases going.
That is a scary thought. It really shows how we can't just focus on how much data there is, but the quality of that data. Like, how well does it represent the real world?
You got it. That's exactly where humans come in. We
Mhm.
can't just blindly trust AI to be fair and impartial. You know, we have to really think about what they're trained on and what could go wrong.
So we need people from different fields, people who study ethics, social scientists, legal experts. We need all of them working with AI developers to make sure we're using this technology the right way.
Absolutely. It's not just about building AI that's intelligent. It's about making sure it lines up with our values
Right.
and, our ethics.
This has been such an eye-opening deep dive for me. It's made me realize how much we use plausible reasoning everywhere. It's not just for mathematicians or scientists. It's like built into how we live our lives, how we decide things, even what we believe.
And I think with AI getting more advanced and being a bigger part of our lives, well, understanding plausible reasoning is even more important now than ever. We need to know its strengths and weaknesses, both in ourselves and the AI we build.
Yeah, it's almost like we're moving into this new era of critical thinking, one where we have to tell the difference between fact and fiction, sure, but also between good reasoning and bad reasoning. And that reasoning could be coming from a human or a machine, you know?
You said it perfectly. We've got to have the tools to evaluate all these claims, to weigh evidence, and to make judgments in a world where we're constantly bombarded with information. and misinformation too.
This has been honestly an incredible deep dive. We've learned about the patterns of plausible reasoning, seen it in action in different areas, and talked about all the challenges and opportunities it brings in this age of, super advanced AI.
And as always, we like to leave you with something to think about. As AI keeps getting smarter and smarter, where do we draw that line between human judgment and AI's reasoning? Like, can we even create AI that's truly objective? Or will they always, in some way, reflect, the biases and the values of the people who made them?
Those are some really deep questions. But for now, we encourage you to think about how you use plausible reasoning. What assumptions do you bring to the table when you see new information? And how do you decide what to believe when you're not 100% certain?
Being aware of how we think can help us make better judgments, navigate this complicated world we live in, and use these really powerful tools we have in our minds the right way.
Thank you so much for joining us on this journey into plausible reasoning. Keep exploring, keep asking questions, and keep using those incredible human minds of yours to make sense of everything around you.